So if you have a straight line, so this means that y varies directly with your x. Okay, so dependent variable changes linearly with the independent variable. So if you have a straight line, again, the dependent variable changes linearly with your independent variable. And if you can remember that the equation is given as y is equal to mx plus b, wherein m is the slope and this is the y-intercept. Y-intercept. So these are two examples of linear graph, wherein the first one here, this gives you a positive slope, and the other one gives you a negative slope. This line here is your negative slope. Well, the slope could represent certain quantities. Let's say, for example, if you're graphing distance versus time, slope gives you the average speed of your object. So if you're talking about the y-intercept, this is the value of b here. So that is your b. So this is the y-intercept of this graph, and this would be the y-intercept of the other graph. So y-intercept is just the point upon which your line hits the y-axis. So that's how we define the y-intercept. Okay. So quadratic relationships. Okay. So when a ball is dropped, the distance versus time graph will not be linear. So this data represents a quadratic or parabolic function. So if you can see in the previous one, again, you can write it at y is proportional to x. So if you can see in this graph here, this is a quadratic graph. Maybe what you're quite familiar of is that the whole parabola thing. But usually the negative, we don't have a negative time. So it follows this one. Well, we'll be doing free falling. So we will study the motion later on when we talk about kinematics. But the graph of a falling object would look like this. Okay, so maybe the position here, this would be taken as just the distance, or you take the downward as your positive. You can also do that. But anyway, when you try to graph the motion of a falling object, it should give you this form here. And this particular graph here is a parabola or quadratic function, and the equation is given by. So if you can see, this is another way. If your data points is something like this, don't make a straight line, because the one that fits all the data points is a parabola. So the equation of a parabola is given by ax squared plus bx plus c, where a, b, and c are just constants. So if you can see here, a quadratic equation, it only means that you have a square in your variable x. And this relation shows that y varies directly with the square of x. Okay, so see the difference. If you have a linear one, so a straight line, y is directly proportional to x, or y is proportional to x. But if you have this graph here, if the graph is something like this, you would expect that it's not a linear graph, but somehow curved, a parabola. And again, yeah, y is proportional to x in this case, the square of x. So it's no longer y directly proportional to x, but y is directly proportional to x squared. That means that if I'm gonna square the value of x here, and then I'm gonna plot it again, I should get a straight line. Okay, so that means that all of the value of x here, if I'm gonna take the square for the same position, if I'm gonna graph them again, I will get a straight line. So that's the meaning of this, that y is proportional to the square of x. Okay, and inverse relationship. So these are just some of the common relationship that you will encounter in your study of physics. So inverse relation tells you that as one quantity decreases, well, as the value of x, if you can see here, as the value of x increases, the value of y decreases. Okay, so some particular common quantities that follows this relationship is the current versus resistance. Okay, the gravitational force versus the distance. So that means that if you increase the distance, the gravitational force decreases. Okay, so as well as current versus resistance. That means that if you increase the resistance, current should decrease. So if you have that relation, we call that one inverse relationship. So they exhibit inverse relationships. Okay, and the equation is given by just y is equal to k over x. Oops. So y is equal to k over x. Or again, if you're gonna say the relationship, y is inversely proportional to 1 over x. Okay. So same thing as before. That means that if I gonna do the inverse of, or actually, if you can see 1 over x is just the same thing as like taking the reciprocal of x. So if I gonna graph that one, the value of x, but trying to get the reciprocal, I should get a straight line. Okay. So again, this particular relation tells you that as x increases, y decreases. So if you increase the x value, the y value decreases. So if in that particular case, that would be inverse relationship. So any questions about the three? Well, these are just some of the common relationships that you will be encountering, especially for the first one and the second one, because when we talk about projectile motion and freely falling object, the motion of those follow a parabola. If you're gonna graph the position against time, it's a parabola. But for objects moving with a constant velocity, well, in that particular case, you're gonna be getting, if you're gonna graph the position against time, you'll get a straight line.